To understand why a room inside the Great Pyramid behaves like a machine, we need to go back into stone, into sound, into a forgotten blueprint. The anomaly inside the stone, resonance that shouldn't exist. Start with what we can measure. The king's chamber is a granite rectangle, about 10 by 5 by nearly 6 meters, built from Aswan granite heavy enough to crush anything beneath it. Yet when sound hits it at around 121 Hz, the room wakes up. Engineers like Tom Danley documented a primary Eigen mode right there, in the lower male voice range, the sarcophagus. It locks in between roughly 114 and 122 Hz, like it was tuned to the same note. That's not myth, that's instrumentation. Why does that matter? Because granite isn't just rock, it's a composite with a lot of quartz. And quartz is piezoelectric. Press it, bend it, vibrate it, you get charge separation. That's how lighters spark and watches keep time. Now in engineered devices, crystals are aligned to maximize the effect. Granite's crystals are mostly random, so skeptics say large-scale electricity from granite is unlikely. Fair. But scale and mass do something interesting. Even with randomness, big vibrational energy across tons of quartz can yield small but real electrical responses. It's not a battery, it's a transducer, mechanical in, electrical out. Here's where the anomaly tightens. The sarcophagus and chamber share a sweet spot. Human voice, chanting, drums, even infrasound from the dead-end passage measured near 5.13 Hz. These inputs don't just echo, they build standing waves. Granite ceiling beams resonate up around 300 Hz. Other models push certain modes down into infrasound. Meanwhile, researchers have reported a stable magnetic environment in the chamber, variations under 0.1%, thanks to the mix of diamagnetic granite and paramagnetic limestone. That kind of electromagnetic steadiness is rare in the wild. It's the quiet you want when tiny charges might matter. Now add a second layer. Physics simulations from modern labs modeled the pyramid interacting with long radio wavelengths, hundreds of meters, and found energy can focus in the internal chambers and beneath the base when driven at specific frequencies. That's a theoretical model, not proof of ancient usage. Still, it shows the geometry is acoustically special, only it's interesting under the right conditions. Geometry, material, and frequency conspire. What nobody knew at the time of construction, if this was intentional, was language like Eigen modes and piezoelectric coefficients. But they didn't need the terms to find the results. You can tune stone by building with millimeter precision. You can select granite with high quartz content from Aswan and stack it in a box that sings. You can cut a stone chest whose note sits inside the chamber's note. You don't have to say piezoelectricity if you're listening for the right hum, and if you feel the room answer your breath, you don't forget it. Meanwhile, centuries later, Nikola Tesla chased resonance from Colorado Springs to Long Island. His Wardenclyffe tower wasn't tall for nothing. It tried to couple energy into the earth with a 186-foot mast and a deep shaft under it, tied to iron pipes sunk radially outward. He aimed for ground conduction and atmospheric coupling, a world wireless system. He believed powerful impulses could drive standing waves through the planet, letting receivers ring at resonance and pull usable energy from the shared medium. His lab drew on big coils, high-frequency currents, and a massive ground connection. While that was happening in Shoreham, the Great Pyramid had been standing for 4.5 millennia with its own unusual pair, a vast tapered antenna of limestone above and a granite heart inside. One focuses mass and shape toward the sky, the other sits like a resonant core. Different eras, same obsession, make the earth and sky part of the circuit. But there's a problem you should hear. Granite's random quartz orientation means you won't get clean, efficient power out unless the input is strong and the structure cooperates. That's where resonance is everything. In a resonant cavity, small inputs can build large amplitudes. The chambers measured 121 Hz mode, the sarcophagus's matched band, the infrasound channels. All of it suggests a system designed to stack oscillations. The more those oscillations stress the quartz, the more charge you get across microdomains in the granite. Not a power grid, but a process. Impact immediate and human. People inside report the tone pressing on their chest, the air thickening, the sense that a whisper carries too far. Palms sweat, hearts sink to the beat without permission. Instruments show spikes. Chanting in the range energizes the space. If you're a priest, that's ritual potency. If you're an engineer, that's energy concentration. If you're Tesla, you're smiling. Unknown to visitors, the stone's mineral physics sets quiet traps. Every footstep adds microstress. Every vowel harbors harmonics that tickle beams overhead. The sarcophagus's lip shivers when a low drum hits. The room answers back as if the walls are a diaphragm. Energy isn't vanishing, it's pooling in wave patterns between faces of stone in the grain of quartz in an electromagnetic hush designed by material contrast, limestone screening, granite converting. 3 days earlier, someone had told me it's just acoustics. Then I saw the modeling papers showing energy focusing under specific radio wavelengths, and I remembered Tesla's claim that the Earth and atmosphere are conductors at high frequencies. I'm not saying the Egyptians built a radio node. I'm saying their geometry and materials would matter in either story, ritual or machine. The line between them is thinner than we think. This was the moment everything changed for me, connecting the measurable hum of a granite room to the dream of a tower that never worked as planned. Wardenclyffe had 300 feet of iron grounding in a 68-foot metallic dome. The Great Pyramid has a limestone mountain as a dielectric mass and a granite core with quartz-rich plates stacked over a tuned box. One had blueprints, the other has angles and stone, both bet on resonance. In the aftermath of that 121 Hz swell, you can't unhear the pattern. A chamber that behaves like a resonator, materials that answer mechanical stress with charge, a structure that in models concentrates electromagnetic energy at certain frequencies. Nobody's claiming a light bulb glowed there, but the ingredients for energy conversion are present, layered in stone. And once you admit that, the shafts and waterways start to look less like corridors and more like parts of a circuit. The Nile beneath, water as the hidden engine. To understand how stone could become a circuit, we need to listen below the sand. The Nile wasn't just scenery, it was a moving charge carrier, a seasonal piston. Now remember, this plateau once sat over a higher water table, fed by a river that rose and fell like a slow heartbeat. If you think that's just poetic, here's where it gets practical. Moving water through porous limestone creates pressure gradients, ion transport, and streaming potentials, electrokinetic effects that turn flow into charge separation. It's weak in a glass tube. It's not so weak when the tube is a hill of limestone the size of a small city. What nobody knew at the time, because the evidence is scattered in shafts and weathered channels, is that Egyptian builders engineered with water more than we admit. Recent archaeological work at the Step Pyramid points to hydraulic lifts and flood control features being used to raise blocks. That's a different site in a different century, but it proves a mindset. Harness water, modulate it, trap its force, then let it do work. Transfer that mindset to Giza and the question shifts from was there water to how was it guided? Here's a micro story. A worker lowers a jar down a narrow shaft near the plateau's base. He hears the echo of a void and the slap of water on stone. He measures with a rope, feels a tug, pulls up a wet line flecked with calcite. His stomach tightens at the sound of moving water under rock. He doesn't know electromigration from a hole in the ground, but he knows a flow when he hears it. That's the human detail the geology hints at. Channels, wells, and cavities that likely connected the monument to a living aquifer. Meanwhile, engineers look at limestone and see more than rock. They see a dielectric matrix saturated with ions. When water moves through it, friction at the mineral surfaces drags charge, producing a streaming current and an opposing electric field. The effect is modest per inch, but scale crushes modesty. Push seasonally pulsing water through kilometers of microchannels under a pyramid, and you've built a constant, low-frequency agitator beneath a resonant granite heart. But there was one problem. You need a way to couple that slow geophysical rhythm to the chamber's fast mechanical modes. Enter constrictions, drops, and cavities. Any hydraulic engineer knows you can turn laminar flow into pulses with the right geometry. Narrow a conduit, create turbulence, then let it expand into a void. The flow becomes a drummer. Now place your resonant box, the king's chamber, where the whole mass will feel those regular tugs. It's not that water powered the room like a turbine. It primed the system with a baseline oscillation, a tide that never stopped tapping. What nobody outside the machine shop understood in Tesla's day is that he tried to do something similar with air and ground. At Wardenclyffe, he sank a deep shaft and drove iron pipes radially outward to marry the tower to the planet's conductive layers. The tower's dome talked to the sky, the buried lattice talked to the earth. From their perspective, the Egyptians built the limestone mountain to talk to the sky and sunk their foundations and internal cavities to talk to the ground. Two cultures. Same coupling problem. Now think about materials. Limestone is paramagnetic and a decent dielectric. Granite is diamagnetic and stuffed with quartz. Stack limestone in a vast, tapered mass to shape fields and damp noise. Place granite plates in a tuned cavity at a specific height to sense and convert. Then run water below and around the base to keep ions moving, to keep a potential simmering. The system doesn't need wires if the medium itself carries the signal. Get this, the dead-end passage that whispers at 5.13 Hz sits like a metronome in stone. Infrasound that low lines up more with hydraulic pulses and ground sway than human singing. If those pulses propagated through the core, they'd ride the structure's body, nudging the chamber's stress state, shifting it ever so slightly toward or away from its sweet spot. You chant and the room leaps to life because the baseline is already warm, and you feel it as a slow, undeniable sway in your chest. Skeptics ask, where's the turbine, where are the cables? That's modern eyes looking for modern kit. Tesla's tower had no wires to homes either, the earth and air were the conductors. If a pyramid's function lived in resonance and field coupling, the signatures would be subtle. A stable magnetic hush inside, differential humidity channels, salt crusts where ions congregated, shafts that make no sense if you're only thinking airflow. Meanwhile, something else was happening along the Nile. Seasonal inundation changed groundwater head, pushing and pulling through the bedrock. Every rise loaded the plateau, every fall relieved it. Mechanical stress waves crept into the mass. In granite, stress doesn't just deform, it tickles quartz. Piezoelectric domains answer with charge. It's small, but if the chamber is already ringing, small is enough to matter. This decision to blend water, stone, and sky would haunt anyone trying to label the Great Pyramid a tomb and leave it there. Because once you accept water as a moving part, the oddities align. The precision course levels, the sudden changes in passage geometry, the places where salt blooms, the inexplicable shafts that don't ventilate anything. From their perspective, these are fluidic features and waveguides. Here's where it gets crazy practical. A slow, steady electrokinetic bias from groundwater flow sets a baseline potential. Seasonal pulses add low-frequency modulation. Human ritual voice drum adds mid-band excitation exactly where the granite likes to sing. And if the atmosphere cooperated on rare days, long-wavelength radio energy, the kind modeled to concentrate in the chambers, would ride the pyramid's shape and pool inside. Multiple inputs, one resonant core. Impact, you get a place where energy concentrates across domains, hydraulic, acoustic, electromagnetic, until the room becomes strangely sensitive. People feel it as presence, tingling skin, quickened breath, a sharpened focus that feels like being watched back. Instruments catch it as spikes. A civilization could encounter it as power, ritual, or both. And if you're Tesla, standing on Long Island staring at a silent tower, you'd recognize the logic in stone and water long before the textbooks gave it a name. Granite as a piezoelectric battery. To see how the chamber could turn stress into charge, we need to get intimate with the stone itself. Aswan granite isn't just heavy, it's quartz-rich, roughly a third quartz on average, sometimes more. Quartz is the quiet worker here. When you squeeze it, twist it, or vibrate it, its crystal lattice shifts ever so slightly and separates charge. That's piezoelectricity. In a lab, we align crystals to make the effect efficient. In natural granite, grains point every which way, so the effect is messy and distributed. But that doesn't mean it's absent. It means the energy lives in a million tiny pockets instead of one neat wire. Now remember the chamber's reality. Tons of granite plates, tight joints, minimal damping in a room that loves 121 Hz. When that mode lights up by voice, drum, or infrasound nudges, the faces of the blocks experience cyclical microstrain. It's tiny but relentless. Each cycle nudges quartz domains, pushing charge to microfractures, boundaries, and contact surfaces. If you were hoping for a light bulb, you'll be disappointed. If you're looking for a transducer that biases its own environment, this is where it starts to breathe. Get this, the piezoelectric response doesn't show up as a tidy DC outlet. It shows up as a swarm of local fields, transient potentials, and surface charges that move with the beat. In a stable magnetic hush, exactly what's been measured in that chamber. Those little charges aren't immediately scrambled by noise. They can collect along mineral boundaries, especially where the granite meets air or a different stone. Think of it as a battery that's always charging and discharging in microscopic pulses, synced to the room's heartbeat, subtle enough to ignore until your body reacts first. But there's a problem you should hear. Random orientations cancel. That's the skeptic's anchor. They're right, if your input is weak and your geometry is sloppy, the net effect is small. Therefore, you need resonance to magnify strain, and you need scale so the law of large numbers doesn't cancel everything out. The King's Chamber brings both. Big amplitudes at a favored note impose coherent stress across plates. Coherence is the antidote to randomness. You won't align grains, but you'll align timing. When timing aligns, even scattered domains can add up in bursts. Meanwhile, the sarcophagus sits inside the pressure field as its own resonator, tuned within the chamber's band. That box is more than a prop. It's a sympathetically vibrating mass-focusing stress near its corners and lip. Microtriboelectric effects at contact points, piezoelectric stress in the granite wall behind it. Together they create hotspots where charge prefers to live. Instruments catching spikes in there. That's exactly how a granular battery would whisper. What nobody in the tour groups hears is that piezoelectric systems often need a load path. Where would charge go in a stone room? To edges, to seams, to any conductive contaminant. Groundwater salts migrate, copper flex, human sweat, even humidity change surface conductivity. Over time, ions crust in certain niches. Those white salt blooms some dismiss as mere efflorescence. From an electrical perspective, they're also evidence of ion traffic. Not proof of power generation, evidence of a medium ready to carry it. 3 days earlier, I reread Tesla's notes on resonant receivers. He obsessed over Q factor, the quality of resonance. High Q means energy sloshes without dying. The king's chamber behaves like a high Q box at its fundamental. Every chant deposits energy into standing waves. Every drum beat primes the quartz. You don't need wires if the whole interior is the circuit. The limestone mass outside acts like a dielectric shell, muting external noise and shaping fields. The granite core acts like the active element, converting mechanical rhythm into electric temperament. Here's where it gets practical. Imagine 3 inputs: ground pulses from slow hydrology, mid-band acoustic drive from ritual sound, and occasional long-wavelength atmospheric energy the geometry prefers. Each input stresses quartz differently. Together they create a layered bias: low, mid, and rare high. The piezoelectric battery then doesn't sit at a fixed voltage, it oscillates. Oscillating fields can do work without wires, polarizing nearby materials, influencing ion drift, even aiding weak corona when humidity spikes. People in that room report hair raising, skin tingling, sound turning physical. That's physiology reacting to field and pressure. But there was one more problem: efficiency. Modern piezo devices convert with single-digit to low double-digit efficiencies when engineered. Natural granite won't match that. Therefore, the output must have been purpose-fit, not lamps, not motors. More like field effects, energizing a space, driving subtle electrochemistry, or feeding a process that only needs low current but benefits from persistence, like plasma discharge at sharp edges or catalyzing reactions in trace gases. If you're thinking ritual, that's a charged atmosphere. If you're thinking technology, that's a reaction chamber. Impact immediate and human. A priest hums and the room replies. A watcher's instrument ticks in bursts. A civilization frames it as a meeting with gods because the experience is undeniable. From an engineer's view, granite became a time-based battery, charging on stress, discharging into the air and into the stone's own seams. It didn't light a city, it tuned a field, and in Tesla's language, that's still power. The shafts, waveguides, or ritual ventilation. While we've been inside the granite heart, something else has been staring at us from the walls. 4 narrow shafts, 2 from the king's chamber and 2 from the queen's chamber, cutting through stone on razor-straight paths. For years they were called air shafts, even though 2 didn't reach the outside until modern tunneling broke them open. Air for what? A sealed room. That label never sat right. If they're not for breathing, what are they for? Start with dimensions and behavior. These channels are small, handspan wide, tight tolerances, polished in sections, and angled upward at precise inclinations. The northern king's chamber shaft doglegs around a block like a wire avoiding an obstacle, then continues straight again. The southern shafts point toward regions of the sky tied to specific stars in the Old Kingdom. Ritual alignment, absolutely plausible, but alignment doesn't cancel function. You can honor the sky and still build a device. Here's the stakes: if these aren't vents, they're intentional conduits, waveguides for something subtle, pressure pulses, sound, or low-frequency electromagnetic fields. In a resonant system, even a narrow channel can tune energy, bleed it, or feed it.